Hi all, I hope you're having a good day. Ms. Perez here again with our next physics lesson. So today we are going to be studying the relationship between current, voltage, and resistance within a simple circuit. Right, so the relationship, this is Unit 6, Lesson 11a. We are dividing this lesson into two so we can dive into it a little bit deeper. So far, we have used simulations to help us make sense of how electric currents work and the different ways to represent them. Today, we will learn about key relationships between current, resistance, and voltage. In order to understand today's lesson driving question, what factors affect the flow of charge through a circuit? We're going to be answering this question by independently working with a simulation. So this is going to be predominantly you doing something on your own, which is great. All right, so how we're going to do that is first we are going to be gathering some evidence, and then we're going to do a check for understanding, make sure we're all on the same page, and then we're going to move on to making some conclusions based on the observations that we did. That again is also going to be predominantly independent, and then we'll do a check for understanding at the end, so we can all be on the same page, and then we'll go over some key points at the end. All right. So before we move on to our simulation, I would like you guys to answer this question in your classwork document. Based on what you understand of simple circuits so far, what factors can affect how brightly a light bulb glows? Right, so answer this to the best of your ability with what we've studied so far. And just take the next minute or so to answer the question. You can press pause when you're ready to start and then hit play again once you're ready to come back. All right, press pause now. Okay, welcome back. So we are going to answer this question more in depth. By the end of this lesson, the answers will become more clear, but we're gonna really stamp the answer to this question tomorrow morning. So let's hold off on your answers, and then we'll see if you were correct or not, yes, tomorrow. Okay, so let's start with our exploration. You should just, you should have this link in your classwork document. I'm going to pull up mine. So in your classwork document here, you have today's activity. It starts off with our purpose here that says that the purpose of this activity is to determine a mathematical relationship between voltage, current, and resistance for a simple circuit. And there's this link here. So you should all click on this link and open it up. And when you do that, actually, this page will show up. So then just click here on the Launch DC Circuit Builder, and that will bring you to this page here. Right, I'm going to guide you through the first part of the activity just to make sure that you understand how to use this, and then we're going to move on into you solving the rest of this on your own. Okay, so the first part here is asking us, so I'm just going to be reading the directions. It says, clear your workspace by clicking on all the components. Only the battery should remain. So when you first open the document, the simulation, only the battery's here, so that's fine. So you should just have your battery. And then it says, using the tools in the toolbox area, create a simple circuit consisting of a battery, a bulb, an ammeter, which is a device that's used to measure current, and then wires. All right, so let's do that. We have battery, a bulb, an ammeter, and wires. Okay, so I'm gonna maximize this so it's easier to see. So here I have my battery, and then we were told to put in a bulb, which is this guy here. So if you just click on it, and then you click wherever you want it to show up in your circuit, it will just pop up. Right, and then I wanna put my ammeter. I'm gonna click on that guy. So this over here in the bottom right is the ammeter. And I'm going to put it right here. I'm going to connect it directly to my light bulb. And then now I'm just going to close my circuit by adding wires. So here I'm just clicking on each section. And lo and behold, my circuit turns on. Here I can see my current traveling, and this represents the brightness of the bulb. So now let's follow the next instruction. So it says select the modify icon over here. It looks like this, and observe the magnifying glass that's going to appear over the battery. This indicates that you can change the voltage of the battery and then use the arrows to lower the voltage to 6. All right, so let's do that. I am going to click over here, that's the modify, and see the magnifying glass shows up over the battery. And then here I can change my voltage now. So I'm going to lower that to 6. Okay. Now the ammeter reads the current, which is represented by the letter I, in amps, and record the ammeter reading in table 1. Right, so here I have my voltage, my table 1, the voltage is 6. So here I'm going to write, my ammeter says 0.6, so that's what I'm going to write here. 0.6 is my current. Okay, so you're going to do this. You're going to repeat. The next step is to increase the voltage to 8, 10, 12, and 18 and 24. Again, you do that by putting the magnifying glass over the battery and then changing this. Right. So as you change it, how does the current change? Right. And then at the end, it's going to ask you over here to find what the resistance of the light bulb is, and you can find that by putting the magnifying glass over the light bulb. So you don't have to drag and click, you just click and it moves. Okay? It's not like the other FET, it's not like the other FET simulation where you click and drag things, you just click on the thing itself and it will, on the icon itself, and it will move around. And so hopefully that was clear. And you're going to do that for the same procedure for table 1, 2, and 3. You know, take the next 15 minutes to do this, and once you're done, once you're done, then come back to the video, and we're going to go over some key points. You can press pause now. Okay, you should be done by now. So let's go over some answers. So our first check for understanding is, I have here the answers for all of the tables, table 1, 2, and 3. The reason why I'm giving this to you guys is I want to make sure that you were able to fully you were able to answer each one of these tables properly, because the next questions where we're drawing our conclusions are heavily based on this. So I just want to make sure that we're all on the same page. Right, so you should have found that the resistance for the first light bulb is 10, and then the resistance for the second light bulb would be 20, and the resistance for the third light bulb is 30. And then here, in the first example that we saw that I modeled for you, the current was 0.6, and then as the voltage increases, then the current increases in this way. And then over here, the same, as the voltage increases, I have this 20 ohm resistance, and then my current increases in this pattern. And over here, my resistance is 30, then the voltage increases in the same way as the other ones, but then my current increases in a different type of pattern. And so if your classwork looks different than this, please fix it so that it mimics what's on this table. All right, so now that we have the right information, so now let's go ahead and make conclusions. So you're gonna take the next 15 minutes to solve the problems 7 through 12 that follow the simulation. All right, make sure to use your claim, evidence, and reasoning to answer the questions that are highlighted. All right, you can press pause now, and when you're ready to come back, press play so we can go over some answers together. Alrighty, so finally, Our second check for understanding, we're just going to answer the last question. This is predicting the values and if the following trials were performed. So question 12 gave you some voltages and it gave you some resistance, and then you had to predict what, or in this case you have two resistances here and then a current. Then you had to predict what the currents were and what the resistances were. If you were able to make it, if you were able to figure out what the pattern between them were, then you would have noticed that the current here is 2.4 amps. The voltage, the current for the second one is 0.3, and then the resistance for the last one is 1.5. You should have noticed that if I divide the voltage by the resistance, then it gives you this value here. So 24 divided by 10 is equal to 2.4. The same thing is true here. If I divide my voltage by the resistance, so 12 divided by 40, it's going to be equal to 0.3, so that gives me the current. Then over here, I have my voltage and my current, and the same thing, actually I can divide these two, turns out, and it will give me what the resistance is. So 6 divided by 4 is going to give me 1.5. And so you can add these into your notes. All right, so now we're going to go over some key points that you should write into your notebooks because these are very important and we're going to be using them for the rest of this unit. So a key point is that in an electrical circuit, the resistance is the opposition to the flow of electrical current. And the unit for resistance is called ohms. So we talked about resistance a little bit back at the beginning of this second part. I think it was in lesson 9. So resistance it opposes the flow of electric current. There are times in which we want to have the electrical current kind of like slow down, quote unquote, and that's what the function of a resistor will be. And then they're measured in ohms, not like the ohm, but as in it's named after a German physicist whose last name was that. And then Ohm's law, Ohm, this German physicist, was the one who understood the relationship between these three quantities, so the law was named after him. So Ohm's law represents the mathematical relationship between resistance, voltage, and current. And the expression for Ohm's law is equal to the resistance is equal to the voltage divided by current, but most often you'll see it written as V equals IR. So voltage is equal to the current times the resistance. That's a really important equation that you should have derived. You should have been able to see through the observations that we made, but if you weren't able to figure it out, then please write this into your notes. It's super, super important. And again, we're going to be using this throughout the rest of this unit. Resistors, and the last point on the slide is that resistors that obey this law are called ohmic. Right? So not all resistors behave in this way, but for our purposes, every single resistor that we're going to look at will be ohmic, and that means that it follows the relationship of V equals IR. Okay, make sure all of these are in your notes. And the last point is how to measure current and voltage. So to make measurements of these quantities in a circuit, it's necessary to use an ammeter and a voltmeter. So if we have a circuit, like in this simulation that we just did, we used an ammeter in our circuit to be able to measure how much current was going through. So when you are adding an ammeter into a circuit, you have to connect it directly to in the loop within the circuit itself. So see here, this is, if you follow along from the battery through the resistor, and then you see here, the loop goes through the ammeter. So that's how you would connect an ammeter. And the voltmeter is connected to measure the voltage across any component in your circuit. But instead of connecting it like in the loop, you have to connect it kind of like sideways to the thing you're measuring. So here we're measuring how much voltage goes through the resistor. You could also have a voltmeter connected on the other side of the battery as well. All right, so make sure you write this into your notes and also write down this diagram as well. Alrighty, so wrapping up, make sure you complete your classwork document, submit it to Google Classroom by the end of the day, and I hope you have a wonderful, fantastic day. Take care.